Everybody, this is Todd Frazee, and this is the S60-127 cam project for the flywheel. This is a 3-operation part, 2 operations on the lathe and 1 on the mill. Okay, let's go to the real deal. And here we are, and we're going to create our first job, which is going to be a lathe turning. And we're going to go to a S60-127 op 1 for the lathe. And we're going to go with a cylinder. And the axis for that cylinder is the same as the large piece. Our drawing says the outside diameter of the part is 1 inch 940 thousandths. We're going to start off with 2-inch stock. But prior to setting stock, we're going to set our origin. So we want it to be again on Z-axis and X-plane. We're going to select the face of the part. As we've done before, we're probably going to need at some point the sketch for this part because of the uninterrupted cuts of the pockets. So we're going to go to the initial revolve and make that sketch visible. And we want to make sure that our X-axis we set is in the same axis as that sketch. So again, we're going to go Z-axis to the face, and then our X-axis is in the same axis as the sketch. Okay, so this is the orientation you want. It's in the same, you can faintly see my sketch here. You want the X-axis in the same plane. And that way we can use the features of it to drive lathe toolpath if we're having trouble with the model driving it. Okay, we're going to scroll down. We're going to put in our program number, 127.1. And it's the S60-127 op 1 for the lathe. Okay, now we need to scroll up and set our stock. I do have a lathe that's big enough to take a 2-inch bar. Some places don't. If you didn't, you would have to pre-cut this off as a disc. We're going to follow the same process we've used on everything else and put 2 inches on the back side offset, assuming that we have a lathe with enough throat capacity to hold that. And the amount of material that's going to be in the chuck, 1.6. And our front side stock offset, we're going to set it 0.02. And then our radial offset is going to be 2 inches minus 1.94 in brackets divided by 2. Which gives us a 30 thousandths per side offset of extra material. Okay, so we have our X-axis in the same plane as our sketch, but we actually need it pointing in the same direction as our sketches, so it's on the top half of this drawing. So if yours isn't the same orientation, that's fine, but we want the red arrow pointing in the same direction as where the geometry actually is on the sketch. So we're going to select reverse X, and then we can always rotate our view so that we're looking at it as if the operator would in the machine from an angle from the controller. Okay, we're going to accept that. We're going to change the job number, S60-127 op 1 lathe. Okay, so we're going to go to turning face. And we're going to select from our library the lathe tools, tool number 1, it's our grooving tool. Now it looks like it's gotten quite a bit of it right. We're going to switch to feed revolutions per revolution. This is a fairly large part, so we want the spindle to increase as it gets closer to the part. So it's going to use a constant surface feed. Let's go to geometry. I don't think we need to select any geometry for this. We are going to go to the next tab, and we're going to take all of this at default, but we're going to go 0.01 deeper than our model shows. Okay, go to the next tab. We're going to use wear compensation. We'll leave the rest the same. We're not leaving any stock. We're going to go to the last tab. And as I have been with this tool, I don't want to have the lead in and lead out the same. So we're going to set the lead in at 90 and the lead out at 0. The lead out's less critical, but that'll make sure that the tool feeds straight in. Okay, we're going to select OK. Okay, we're going to use the same grooving tool to do a single groove command to cut down to this hub and face off the outside of the part down to that hub. And so it'll terminate right where my cursor is. That routine, we're going to go turning. And we're going to go down to single groove. And we're going to select from the tool library the same tool we've been using. So it's tool number 1. It's the grooving tool and cutoff tool. Okay, so now we're going to go to the next tab, which is the geometry tab, and we're going to select our groove. Okay, you'll notice I'm using the section view that I made that's of the turning. So I switched over to that because for this particular operation, the chamfer was giving it a trouble off the other sketch. So if you select it, you should be able to select the line near the hub, and then you have to change the orientation of the side alignment to front, and you want it on tip. Now we're going to go to the next tab, and we're going to leave pretty much most of this at default, except for we do need to set minimum OD at the model, because right now we're cutting the hub off. So we're going to go to selection, and we're going to select the hub itself, which will stop the diameter of our cut at that height. Okay, going to the next tab. We can leave pretty much this tab at default. Then we're going to go to the next tab. We're going to leave that at default and select OK. Okay, we should have a groove that comes down right to the face. So it's going to machine the face down to the hub level, pretty much facing off most of the material on the face that's positive. And we're left with a chamfer and the pocket in between to do. So there's several ways to approach this. How I'm going to approach this is we're going to cut the chamfer. We're going to come with the same OD tool that we use on the outside. And then we should be able to take that toolpath that we generate for the hub. We should be able to regenerate it for the top to go over the top profile, cut the chamfer's outside edge. Before that though, I want to have it set up so that there's a groove on the back side, so that when that cutter goes around over the top, it doesn't have to be under heavy load on the back side of the part. So we're going to use a similar grooving tool so that when it comes around the corner here, we're not digging into stock in that zone there. So what we're simply going to do is copy the turn single groove we used on the front and change the parameter so that we can use it on the back side. So let's right click on that, and we're going to duplicate, and we're going to open and edit that copy. And we should be able to keep everything on the first tab pretty much the same. We're going to go to the geometry tab, and then we're going to pick grooves, and we need to zoom in on the little tiny boss that's on the back side. And that's where we want our groove associated with that edge there. But we don't want to cut all the way down to where that groove is. Right now, the default settings are taking it, if we were looking at the side view, and stopping where we've set the limit for the groove that we've copied, which is the diameter of the hub. And even that's too deep. We don't want to go that deep because all the other cutting we do on the rest of the part will lose rigidity from this cut, taking it down to the small diameter of the hub. So what our goal is just have clearance for the cutter that goes over the top. And so we want to cut a portion of this profile, and so that when we go over the top it doesn't gouge on the back side. So we're going to set a different length. We're going to go, instead of using that face, we're going to select the horizontal line of the bottom of the hub, and that should give us plenty of clearance for the material for the cutter to come over, and it leaves the gap so that when we come over with the tool it goes into a cavity instead of gouging into material. And it'll allow us to run that tool faster and don't worry about damage. Okay, next tab, we're going to leave all that at default. We're going to go to the next tab and leave that at default and accept the results. Okay, so here we go. We've got our notch on the backside, and we can move on, and it's going to stop at the point on my cursor. One nice thing about using this method, we can now copy this and then we can reapply it when we're ready to cut all the way down to the hub. And we'll just use the same parameters, and we pretty much just have to change the inner diameter. So the strategy I'm going to take is I'm going to first do the toolpath for the chamfer in the front, and then I'll apply a modified version to the top. In order to do that, though, we need to switch back to our other sketch. So let's go back to our model, and we're going to switch back from the sketch we used to sweep the entire base shape with. We're going to hide it, and we're going to make the lathe profile that we created visible, because we need the chamfers at this point to do this tool path. And then we're going to skitter back to the right. Okay, so let's go up to turning, and we're going to do a turning profile. And we need to select from our tool library the lathe tool library, and we're going to select tool number 3 as our turning tool. Okay, so this is our primary turning tool. It's huge in comparison to the part. Okay, so we're going to move on to the geometry tab, and we need to select the geometry for the first chamfer we're going to do, which is the one down at the hub. So we're going to select the box that says model, and this allows us to select geometry to use instead of the model itself. So we're going to pick the edge of this one chamfer, and we can leave the tangent propagation alone. Now we're going to move on to the next tab, which is the radii. We'll leave the clearance and the retract at default. So then we're going to move on to the next tab, and we're going to change some parameters here. We're not going to do roughing passes. We've already roughed all the material out. We want to go to wear compensation. Now we're going to move on to the next tab. Okay, so then we're going to change the retract for the lead outs at 90 degrees, and we're going to set the linear lead out at 0.08 and hit accept. And there we go, we've got our toolpath that's cutting just the chamfer. We got to be careful because this cutter could gouge into our part. We don't want to get too close to it. Okay, so we're going to now look at the other area, and we're going to simply copy this toolpath to cut the outside profile. We may have to make a few adjustments. So we're going to right click, we're going to hit duplicate, and duplicate the toolpath. I'm going to go to edit, and we're not going to select that same line. We're going to use the same tool we've been using, and we're going to select new geometry, which is going to be this outside profile. And I'm going to leave the 20 thousandths extension because I want to make sure we cut all of that chamfer, and we'll leave the front alone. Let's go to diameter. We're going to leave all that default. Okay, we're going to next tab. We do want to allow radial grooving, and in this case we do want to do some roughing passes. We want to take down on the exterior combination. Again, our roughing passes, we don't have 40 thousandths to remove, so we want to do one finished pass, and we want to make that at 10. Okay, 10 thousandths. We'll leave the maximum step over alone. And we'll go to the next tab. We're going to leave this at default. We'll hit accept. Okay, so it looks like what we have here going on is a series of rough cuts. One that hits just the chamfers, picks up, hits the chamfer area, then it cuts the whole entire exterior, and then we have our finish cut. And it's doing what we want. The tip is ending up in this notch we have that we've cut in the groove. Alright, so we are done with the exterior of the part. Let's simulate what we've done so far so you can visualize it. Okay, we have our parting tool facing the front off. Then we have our single groove, taking the boss down to size. Now cutting our relief groove in the back side. Come in and cut a chamfer, a rough cut, finish cut. And now we have the exterior of the part pretty much done. Now we need to do the interior turning. And we still need to drill this hole in the front. So why don't we go ahead and do that. And typically I try to do my drilling when the thing's on center line. I try to do them when the part is rigid. It's good to do it with a lot of mass to pull away the heat. In this part, has a fair amount of mass even after we finish all the machining on the exteriors. But let's go ahead and do that routine, and then that way it's out of the way. So we're going to go to drilling, and we're going to, wrong menu. We're going to go to drilling. We're going to select from our library the 1/2 inch 90-degree spot drill. Okay, after we select that very common tool we've used over and over, we're going to go to geometry, and what are we cutting? We're just cutting the hole here. Okay, we're going to go to the next step, and we're going to again override this. So we're going to go from, instead of stock top, we're going to go from model top. Save a little bit of time. Or we've already turned down the face and the exterior, so the stock's not an issue for this type of operation. And we're going to go from hole top, and then we need to calculate our depth. So it's a minimum material condition. It's going to be a 77 thousandths deep hole, or diameter hole. That's 2 millimeters roughly. 0.077. And we're going to add to that 10 thou. So we have 5 thou chamfer on each side. And we need to put it all in brackets. Divide it by 2. And we need it negative. So at the beginning we need a negative symbol there. Alright, so that gives us 43 thousandths 5/10. Next tab. It's going to be just a straight drilling operation, so we get our cut there. Now let's go to the drill that's going to go all the way through. Okay, and we're going to go over all the way through, as you know, if you can do it. I like to do that so that the parting tool isn't going to center. What should help is, provided this tool goes through straight, it'll also act as a pilot drill for anything on the opposite side, hopefully keeping everything concentric to each other. We're going to go and we're going to switch tools, and we're going to go to our lathe tool library, and we're looking for the drill bit that's for 2 mm, which looks like is the tool number 11. It's a 76 thousandths diameter drill, and it's the number 48 drill. In this application, typically I do reaming. It's brass, soft material. We're just going with a drill bit that we know is going to run a little bit undersized so that we can press fit our 2 mm pin in there. Okay, select that. I want to slow the speed down. This is a fairly small drill bit. We're going to go relatively deep in the scale of its size. So let's go 9 inches a minute. Okay, and then we're going to go to geometry, and we're going to select the hole at the top, and we want to auto merge hole segments, which it's selected all of the ones in line with it. So that's going to be important when we go to the next step. Instead of using hole bottom, when you see something like this, we're going to go to selection, and I'm going to select the back face of the part. Okay, I want that to be the reference that we're using for all our calculations beyond. Okay, not what it thinks the bottom of the hole is. If it, for some reason in my case it's shooting past. All this other stuff can stay at default, but we are going to drill with the tip past, and we want to go past by enough that our parting tool is going to hit that hole and cleanly break off. So we're going to go, let's go 0.14 deeper. I think our width is 130 something thousandths on that insert. And so that hopefully, if that drill bit goes straight when we come in from the other side, we technically wouldn't need a spot drill. We're going to go ahead and go in with a spot drill just so you have a chamfer, but it'll help the other drill bit center on the same center line that it was, all the exterior features were turned at. And on this side is where it bolts on, so it would ensure that that screw bolts concentric to the opposite side. Okay, and instead of doing deep drilling, regular drilling, we're going to do deep drilling. We're going to go half the diameter of the cutter, so it's 0.077 divided by 2. Gives us a peck of 38 thousandths 5/10. And we'll hit accept. All right, we're almost done.